Which is the diagram below is a cuboid A, B, C, D, E, F, G, H. The cuboid has sides of length 6 centimeters, 4 centimeters, and 3 centimeters. Calculate the length of the diagonal BH and give your answer to three significant figures. We use Pythagoras Theorem. HC, let's work out HC, the diagonal, and the triangle, if you like, CHG. So AC equals the square root of 6 squared plus 3 squared. And so BH, right here, BH equals the square root of 4 squared plus 6 squared plus 3 squared equals to the square root of 61, which equals 7.81 centimeters. So the length of the diagonal BH is 7.81 centimeters to three significant figures. Question 8, calculate the area of the field ABCD. Well, here use simple trigonometry to determine AC, right here, AC, and then cosine rule to find the angle ADC. Tan 55, the opposite side, AC, divided by the adjacent side, 85. So AC equals 85 times tan 55 equals 121.4 meters. We now use cosine rule. 121.4 squared equals 105 squared plus 115 squared minus 2 times 105 times 115 cos D. If we rearrange, make cos D the subject. So cos D equals 105 squared plus 115 squared minus 121.4 squared, all divided by 2 times 105 times 115, which equals 0.3939. So the angle D, if you like, angle ADC equals shift cos, gives us cos to the power minus 1 open bracket, 0.3939 close bracket equals to 66.8 degrees. So now let's work out the area of the triangle ACD, which equals half times 115 times 105 times sine 66.8, which equals 5549.3 meters squared. Area of triangle ABC, using the formula half base times height, equals a half times 85 times 121.4 equals 5159.5 meters squared. Hence the area of ABCD equals 5549.3 plus 5159.5 gives an answer approximately 10709 meter squared. So that's the area of the field ABCD. Question 9, the Venn diagram below shows the percentages of female contestants F and singers S in a talent competition. Find the probability that a randomly selected contestant is a male, given that they are a singer. The total number of singers here is 33 plus 21, which equals 54. Number of male singers equals 21. Therefore, the probability of male singer equals to 21 divided by the total number of singers, which is 54. 3 goes into 21 7 times, 3 goes in 54 18 times. So the probability that a randomly selected contestant is a male, given that they are singular, is 7/18. Question 10. Simplify the calculation below as much as possible. 2a minus 8 divided by a squared minus 9 divided by a squared minus 2a minus 8 divided by a squared plus 5a plus 6 times, open bracket, 2a squared minus a minus 15, close bracket. So the numerator, factorizes as 2 outside the bracket, open bracket, 2 into 2a is a, and 2 into 8 is 4, close bracket. We factorize the denominator, a squared minus 9 factorizes as a minus 3 in one bracket times a plus 3 in the other bracket. We change divide to times, so we swap them around. So the denominator becomes the numerator and the numerator becomes the denominator. So we have a squared plus 5a plus 6 divided by a squared minus 2a minus 8 times, we factorize 2a squared minus a minus 15, factorizes as, open bracket, 2a plus 5, close bracket, times a minus 3 in the other bracket. Let's go back. So we write this down here as 2 open bracket, a minus 4 close bracket, divided by a minus 3 in one bracket and a plus 3 in the other bracket. We factorize the numerator, this one here, we factorized it. So it becomes a plus 3 in one bracket times a plus 2 in the other bracket. We factorize this one here, the denominator. It becomes a minus 4 in one bracket times a plus 2 in the other bracket. And then times 2a plus 5 in one bracket times a minus 3 in the other bracket. Okay, so here we can cancel things down, dividing. So a minus 3 here cancels with a minus 3 up here. And a plus 3 cancels with a plus 3 up there. A plus 2 cancels with a plus 2 here. A minus 4 cancels with a minus 4 here. So notice that we're now left with 2 times 2a plus 5 written here. 2 open bracket 2a plus 5 close bracket. Which we can write as, if we expand, as 2 times 2a is 4a and 2 times 5 is 10. So the answer could be written as 2 open bracket 2a plus 5 close bracket or 4a plus 10. Question 11, solve the following pair of simultaneous equations. 2x squared plus y squared equals to 51 and y equals x plus 6. Well, here we substitute y equals to x plus 6. In the equation, 2x squared plus y squared equals 51. So 2x squared plus x plus 6 in bracket squared minus 51 equals to 0. 2x squared, we expand this here, becomes x squared plus 12x plus 36 minus 51 equals to 0. We collect like terms. 2x squared plus x squared is 3x squared. And then plus 12x minus 15, because plus 36 minus 51 becomes minus 15, because when the signs are different, you take away and add the sign of the bigger number. We divide through by 3. So 3 into 3x squared is x squared. 3 into 12x is 4x. 3 into minus 15 is minus 5 equals to 0. We factorize x plus 5. Well, we factorize x squared plus 4x minus 5 equals to 0, which becomes x plus 5 in one bracket times x minus 1 in the other bracket equals to 0. And so x equals to minus 5. When x equals to minus 5, y is 1. Or x equals to 1. When x equals to 1, y is 7. So the answers are x equals to minus 5, y equals to 1, and x equals to 1, and y equals to 7. Question 12. Solve the following pair of simultaneous equations. X squared plus y equals to 4, and y equals 4x minus 1. Well, let's substitute y equals to 4x minus 1 in the equation. X squared plus y equals to 4. When we do that, it becomes x squared plus 4x minus 1 minus 4 equals to 0. If we collect like terms, x squared plus 4x, then minus 1 minus 4 is minus 5. Yeah, when the signs are the same, you add and keep the sign. And so that's why it's minus 5 equals to 0. Let's factorize. So x plus 5 in one bracket times x minus 1 in the other bracket equals to 0. And so x equals to minus 5, or x equals to 1. When x equals to minus 5, y is minus 21. When x equals to 1, y is equals to 3. So the answers are x equals to minus 5, y equals to minus 21, x equals to 1, y equals to 3,